Hello, my name is Paul Clark and I'm one of the co-chairs of the Robotics Growth Partnership, or RGP, the other co-chair being Professor Emeritus David Lane. We're supported by other members of the RGP, some of whom you'll be hearing from during this session, and a secretariat team at BAYS. So what is the Robotics Growth Partnership? Well, the RGP was established in August 2019 by the Right Honourable Chris Skidmore MP, the then Minister of State for Universities, Science, Research and Innovation, who said, "The objective of the RGP is to put the UK at the cutting edge of the global smart robotics revolution, turbocharging economic productivity and unlocking benefits across society." The RGP brings together stakeholders across the triangle of industry, research and government, enabling a two-way dialogue around strategy, ideas and investment. The RGP has jointly influenced policy and funding and is considered a valuable conduit to the robotics community. So what does the RGP do for you? Well, the RGP is your link to the government, representing your interests to ministers and officials in BAYS and elsewhere, also providing a channel to UKRI. The RGP helps the government understand robotics in terms of the benefit it brings, the needs of the robotics community and the priority areas for public investment. It sets the context of robotics in the wider technological and societal landscapes. How does the RGP link with AI? Well, the RGP is focused on the cyber-physical infrastructure for building connected smart machines across all sectors and applications. This includes technologies such as AI, including planning, control and trustworthiness, data, sensing, networking and remote operations, human interaction, digital twins, virtual labs, living labs, and pre-competitive hardware and software building blocks. It also embraces elements of the social agenda such as security, privacy, ethics and trust. The government is championing a joined-up approach to advanced smart technology. It rightly believes that the advantage lies in synergizing smart technologies and doing so across sectors, including the public sector. What does the RGP promote? Well, the RGP considers the broad strategic picture, promoting robotics in its wider context across sectors. It considers the research and innovation infrastructure, the skills landscape, and the international opportunity. It places robotics into the government context aligned to the prevailing national agenda, and in particular, the government's forthcoming innovation strategy. What is the vision of the RGP? Well, the UK has a long established history of punching above its weight in areas such as technology, innovation and thought leadership. We need to build upon this legacy when it comes to responding to the big challenges and opportunities that we now face as a country and indeed as a species. To set the scene for talking about the RGP vision, I'd like to show you a short animation.
Our material economy is built on combining experience, intelligence, and physical action. Over the last 100 years, we have made machines work better for us. In the beginning, these machines worked in isolation, processing materials or information. Communication has now connected them together. The next step is cyber-physical services that connect data and knowledge with physical action. These cyber-physical services are built on digital twins that capture real-time data, human experience, use AI to manage complexity, and robots to deliver physical interactions. Together they weave a cyber-physical fabric that interacts with us and the world around us and does so with knowledge. We have the threads but haven't yet made it easy to weave them together. By building and sharing digital and physical resources, we can create the cyber-physical fabric that makes it easy for everyone to build connected smart machines. The fabric is a connected ecosystem for innovation and collaboration. It enables anyone to go from the idea of a cyber-physical service to virtual testing before trying the solution in a physical testbed and a living lab. The fabric is a new material from which we can fashion all manner of new products and services.
As that animation portrays, we need to equip ourselves with the tools, frameworks, platforms, services and infrastructure to enable us to work smarter, faster, more resiliently, more sustainably and with greater competitive advantage. Technologies such as data, the Internet of Things, AI, digital twins, smart machines and quantum are powerful on their own, but their real power is released when they're blended together as ingredients within an innovational cauldron. Vertical initiatives that need these technological accelerants, whether that be national infrastructure projects, ISCF programs, or institutions such as the NHS, typically lack the time, budget and capabilities to assemble this virtual infrastructure for themselves, let alone to build it at scale on behalf of other initiatives. So our vision is to weave these technologies and other supporting elements into a single cyber-physical fabric. The diagram on this slide identifies some of its key threads. Infrastructure for harvesting data, including crowdsourcing real-time data from sensors, citizens and other sources, combined with the mechanisms to support the controlled and secured sharing of these data. A new open source framework for building synthetic environments, simulations, emulations, visualizations and digital twins to make them an affordable and accessible commodity, especially for startups, SMEs and the public sector. Smart glue in the form of the digital commons for connecting digital twins and synthetic environments into powerful clusters on the journey towards assembling a UK digital twin and ultimately perhaps even a planetary digital twin. Shared synthetic environments to support the end-to-end ideation, design and testing of new products and services, which by driving greater collaboration, coordination and communication will turbocharge our innovation programs. Pre-competitive shared physical building blocks for creating all manner of new smart machines that once woven into the fabric of our everyday lives will deliver prosperity, agility, scalability, resilience and sustainability, ready to be conscripted when exogenous shocks hit. AI as the smarts in these smart machines, but also digital twins that enable AIs to get physical and unearth optimizations that are beyond human scale. Synthetic environments and digital twins providing immersive environments for learning, training and reskilling that not only transform the educational experience, but also provide leveled up access by anyone from anywhere. Maker labs that democratize innovation and foster the next generation of inventors and tinkerers. Virtual labs that enable researchers to collaborate remotely, driving diversity of contribution and sustainability. Living labs that harness the learning by doing paradigm within real-world use cases to accelerate the maturation and adoption of new technologies, but also to foster public acceptance and trust. Baking in standards, security, privacy, ethics and trust by design, whilst adopting an agile, evolutionary, sprint-based delivery model that yields incremental learning and benefits along the journey towards the cyber-physical fabric vision. Harnessing the power of the crowd in terms of the coalition of the willing that has been assembled and is growing. This cyber-physical fabric would be a horizontal infrastructure to support many verticals and moonshots. A fabric that stitches together our physical and digital worlds. A fabric that is a piece of enabling horizontal infrastructure, which would be as transformative as the World Wide Web, and like the web would be owned by nobody but used by everybody. A fabric that would create sovereign capability and defensible competitive advantage for the UK by supporting and enabling our aspiration to become a science superpower. This slide illustrates how the horizontal and vertical threads connect. The bottom three horizontal threads are the cyber-physical web, which use the vertical delivery vehicles on the right to take the four technologies at the centre, AI, shared synthetic environments, connected digital twins and connected smart machines, to create new capabilities which organisations and people will use to create solutions which ultimately drive a family of national efforts. So now let's watch 4 videos that highlight the power of some of these cyber-physical threads.
Hello everyone, I'm David Lane. I co-chair the Robotics Growth Partnership with Paul Clark. I've been using digital twins to develop smart machines with these organizations on the left since I started my PhD way back in 1981. Probably the most impactful has been the autonomous inspection vehicle, co-developed by Seabite and Subsea 7 from around 2005 to inspect deep water floating production systems. We had to develop our own bespoke simulations and emulations to test its flight code, particularly the visual surveying from sonar. Our living lab was Loch Earn and our site lab, the North Sea. In the late 1990s in the Ocean Systems Lab at Heriot Watt, we worked with environmental modelers to run their simulations as digital twins in lockstep with oceanographic measurements from AUVs and gliders. We could nowcast, forecast and hindcast at a variety of scales in space and time. If we'd had the tools to federate these models easily, it would have been the beginning of a planetary digital twin of the Earth. More recently in the Orca Hub, Professor Sethu Vijayakumar's team in the Edinburgh Centre for Robotics have been building environmental maps for assisted teleoperation. These maps are updated in real time and used by both the robot and the operator. It will be powerful to query these maps from elsewhere through federation. Professor Helen Hastie and team have been doing precisely this through the Miriam personal assistant, also part of Orca. Operators can query robots verbally or through a WhatsApp-like interface for explanations and predictions. Digital twins of the asset and robots are the key information stores that make this possible and help to develop trust. Finally, Consequential Robotics' social robot Miro runs a virtual digital twin called Mirror Cloud in Amazon Web Services. Programmers can develop code remotely from anywhere through a browser interface and then download to the robot to test behaviors. This is useful for system development, but also as an education tool to teach programming to children in schools and university undergraduates as a blended learning activity. We've been using digital twins thus for 40 years, but have never had readily available tools to make them easy and ubiquitous to adopt. We believe the cyber-physical fabric is as ambitious and revolutionary as the internet and World Wide Web have been, and we hope you want to get involved. Thank you.
The Self-Repairing Cities project is about using robots to repair infrastructure in a city. For example, robots which will go out and fill in a pothole, or they might fly up to a bridge, or we're even looking at robots to go into the pipe networks and check for leaks in there.
Because of the virus outbreak, Self-Repairing Cities has changed direction slightly to address this new challenge. Robots that were autonomously driving around a city, trying to repair roads, trying to repair bridges, are now being retasked to go into transport hubs like airports and city centres and be able to disinfect the spaces to make them safer for people to live and work.
Public areas often need to be disinfected. There's a lot of areas which get touched by a lot of people. So we're using the same robots, the same algorithms and coding that we've been doing, just realigning that for cleaning areas rather than repairing them.
overall the aim of robots is to be able to autonomously disinfect public areas without putting more humans into unnecessary risk.
It removes people from harm's way. So we've got a couple of ground-based robots that can map an area, and then they've got tanks of disinfectant and spraying arms so that they can spray onto door handles or benches.
Basically any hotspots for the spread of the disease. We're spraying a diluted mixture of alcohol to kill the virus. We're also working with the Leeds City Council so we can put the robots into the public environment, such as the street side public benches and also areas within a train station.
I'd say we're being proactive and responsive. So we've had this vision of what robots can do in a city, and now we've got a real-world example where we can react to the current world situation with this future technology and tackle the problem.
The use of robots and AI represents the future of critical infrastructure inspection, repair and maintenance. Through the ISCS Robots for a Safer World scheme, 4 world-leading research hubs have been developing solutions for use in hazardous and challenging environments, such as those found in the nuclear, offshore and space sectors. The development of robotic platforms which can enter these environments to perform missions is only half the story. To enable their full potential, they need to be connected to digital versions of themselves and the environment through the use of digital twins. These digital twins can be used in a number of different ways. For academics and researchers, they can allow the rapid development and simulation of new algorithms, secure in the knowledge that the performance is similar to the real robot. For operators, digital twins can allow immersive visualization of environments and facilities using virtual and augmented reality. They can also provide real-time updates highlighting critical areas of interest. When it comes to the remote teleoperation of robot platforms, more intuitive techniques can be used alongside approaches such as haptic feedback. This will allow operators to be more efficient, accurate and quicker with their tasks. For the physical and digital systems to interact seamlessly, connective digital tissue needs to be developed. 5G will be required to ensure reliable and high bandwidth communications, which will be critical for linking the digital and physical twins as well as the operator. The use of cloud-based infrastructure will not only allow advanced AI algorithms to be deployed, but will also lead to the use of shared synthetic environments to help facilitate the ideation and design of digital twins. All of these technologies will come together to enable a future where the lines between the physical and virtual worlds blend seamlessly together and where human and robot work effortlessly hand in hand.
So how can you connect with and help support the RGP? Well, our emerging vision is just that. It's not a fully formed roadmap at this stage. We have the kernels of ideas on how to design, develop, build and deploy smart machines at speed for lower cost, and to weave that cyber-physical fabric. However, we need your input to this vision and help with its implementation. For example, what are the barriers that you face in driving the adoption of automation and robotics within your businesses? Do you agree with our emphasis on the importance and opportunity for creating a cyber-physical fabric to unlock UK growth in RAS? And if so, are you already working in areas that could connect with this vision? What do you believe are the must-haves in a future strategy and ambition statement for RAS? How can the RGP continue to engage with the RAS sector? This showcase is an opportunity to connect with the RGP, both in this meeting and at the RGP booth today and tomorrow. All the members of the RGP are chosen for their connectivity to major sections of the UK robotics community, such as the RAI KTN network, the UK RAS network, the National Robotics Network, and major industries and sectors. Members of the RGP are your representatives to the government, so please do talk to them at this showcase and understand how you can influence the RGP today. Please also do check out the RGP website. Thank you very much indeed.
Good morning, everyone. We're delighted to be here with members of the Robotics Growth Partnership, otherwise known as the RGP. We see today as an opportunity to tell you what the RGP has been working on and to get your feedback, continue the conversations we've been having over the past year, really. I'm Sabine Howard. I'm Associate Professor of Swarm Engineering at the Bristol Robotics Laboratory. And you've just heard Paul Clark, who's the co-chair of the RGP. Thanks, Paul, for an excellent presentation. And on the stage with me right now, I have David Lane, the other co-chair of the RGP. David is an entrepreneur and founding director of Edinburgh Centre of Robotics. You heard it from him. He's been doing digital twins and robots for the past 40 years. And we also have David Bissett, a robotics consultant, well known for his work on robotics roadmaps and chair of the KTN's Robotics and AI Advisory Board. We'll be posting a Padlet in the chat bar, so you can all provide feedback over the next 10 minutes. And we'll also have an interactive session afterwards. And we hope many of you will join so that we can have a bit more of an informal chat. And finally, if you have some questions in these 10 minutes, you can also use the Q&A function. So I think we can jump right in. So let's get started. I had a question for David Lane to start. Just to make this a little bit more personal, what does the cyber-physical fabric mean for you? What do you think it would enable? Maybe you have an example for us.
Sure. Hi, Sabine. Thank you. And hello, everybody. Good morning. It's great to be here. As I said in the video, I've been doing this for 40 years. I ought to feel old, but I don't. And my observation has been through all those examples that every time we engineer some of these systems, we go through the process of synthetic environment, simulation, emulation, and working in living labs, and then going out into the field with our systems. And we pretty much reinvent the wheel every time. And that's very inefficient. And wouldn't it be much better if we could learn the lessons from those people who did the internet and the World Wide Web, where we have some standards and some sort of middleware used by everybody, owned by nobody, where you just log into your computer and you're up and running, not just with simulations, but also with the physicality in your lab. So for example, if we're repurposing our robots to do hospital disinfection, I was asked to do this during the pandemic by the Scottish government. We would have been able to do that much better than we were because we were all locked down and we could work from home. So it provides an element of, not only does it make us more efficient, more able to work across organizations, more competitive, but it also makes us more resilient to the next pandemic or the next challenge that we face as a nation.
So we have an excellent question from the crowd, which says, the vision sounds fantastic, but is it boiling the ocean? It sounds like this is going to solve every possible fabric. Are the goals realistic? I think the question is the fabric too big? Did you want to have a go at that, David Lane?
So I know what you mean, and it does feel like that. You could have said the same thing at the start of the birth of the internet in the early 70s, late 60s with ARPA, and indeed at the beginning of the World Wide Web and Sir Tim Berners-Lee. And you're absolutely right. At the beginning of those initiatives, they were focused on specific problems. Tim Berners-Lee was focused on trying to get data off servers across CERN, and ARPA were concerned with trying to connect their computers. So you're right, we need some specific examples of projects we can work on that will develop this. There are some very big ones in environmental science at the moment and planetary digital twins that we're involved in. And we do it in stages. So you start with things that are simple and demonstrate both to the public and politicians and to ourselves that this is going to work and incrementally move forward.
We often get questions about what the RGP is doing. I wonder, David Lane, if you can tell us how you see our role at the RGP and what we can hope to get out of it. Sure.
So I've been doing this kind of role inside government since 2003, I think, with what was the RAI SIG. And we wrote a strategy document back then. We had the attention of the minister at that time, it was David Willetts. And if you look at some of the resources that have gone into the ISCF programs we've just heard about, for example, the Orca Hub, the Rain Hub, and all those programs that Andrew Tyra was talking about yesterday. And indeed, some of the work that's come down into self-driving cars and the infrastructure around that. That was a direct result of the work we did with ministers and government at the time. So I think there's a really important role for a small group with the convening power of ministers to hold government, to hold their attention, to show them the opportunities, and ultimately to get resources to flow to support the innovations that we all know we want to do. I think that's our role, and to represent the community in order to do that. And that's why today is really important. We need to hear from you. We want to work with you. We're not working in a bubble on our own. You know, we need to galvanize the community around the things that people really want to do.
Okay, and a question for David Bissett. Weaving this fabric with all its building blocks feels like quite an endeavor, as the public question related to. Why do you think the UK should be driving this effort forward?
Well, you're right. It is quite an endeavour. I mean, as Paul said on his intro video, that we're looking at national infrastructure, and obviously that is a big win if it is national. So it is an endeavour. So why should we do it? Well, I think there are two reasons for that. One is we have a large amount of expertise in all of the component parts. So we have excellence, obviously in the research base, but also we have large organizations and large companies who are using these technologies independently, and tying them together and connecting them to national infrastructure will be a big gain. The second reason is obviously the data, the information. A lot of the digital twin side of this is very specific. It's specific to a geographic location, or it's specific to an asset, and its value exists at that point. And so there is a great need to do this. But I think also it's about the fact that we have some capability to produce things which would have a global context. So certainly the work that we're doing in offshore, in nuclear, in various other areas have got a global context. And so there is an exploitation that could be had for the UK in terms of those markets. And I think, it is important for the UK to get involved in doing that. And other organizations around the world, other countries, other regions are also doing the same thing. They're looking at the same types of building blocks and how they would join together. So in Europe, there's a new partnership going on with the European Commission around AI data and robotics. So a lot of places around the world see the opportunity of joining these things together and making sure that we have a good capability.
And we keep talking about an ecosystem. How do you see different actors interface with that ecosystem, whether they're industry, the public, researchers?
I think obviously at one level, it's events like this, 3 days of people getting together. It helps to sort of put a sort of wide angle lens on the community so that everybody can see what's out there. They can test and see the range of stuff that's going on. But also this is why we're talking very much in the RGP about this layered landscape of having living labs, of having open access, and making sure that there are these different layers and different access points. Obviously, how you access the ecosystem, and obviously ecosystems are distributed. They're not sort of in one place, they're all over the place. So therefore they do need maps, they need signposting, and organizations like the KTN and obviously UKRI provide bits of the landscape map to help you navigate. So it depends really very much where you're coming from, whether you're an SME or a large organization or indeed a member of the public. Then we need to do that public engagement piece as well, because these technologies, when they're applied, they will in some senses be disruptive and they will have an impact.
All right, I think that's all we have time for in these 10 minutes, but we have an interactive session following up. So please join us for an informal chat, or if you had some comments, fill them into the Padlet. We'll be reading that after the event. So thanks everyone for this wonderful session, and see you in 1 minute.